Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics and the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2009, second session, first exercise. The title of this exercise is Roles of a Converging Lens. The aim of this exercise is to show that a converging lens may have different roles. For this, we consider a converging lens L of focal length f is equal to 4 cm and an object AB of height AB is equal to 2 cm perpendicular at A to the optical axis of the lens. Then part 1 of this exercise, the first experiment. The object AB is placed at a distance OA is equal to 6 cm from the optical center O of L. The diagram below, they mentioned the diagram, so now I can use it. Shows L, its optical axis, its two foci F and F' and the object AB. Number 1, they are telling me reproduce on the graph paper and do the same scale the above figure. Notice that here the direction of propagation of light is not indicated, but we take it as in the same direction of the positive x-axis, which is from left to right. And whenever we need to redraw, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. This is x prime, and this is x. Then we place the lens L perpendicular to the optical axis at the center, having the correct symbol of a converging lens. And we know that the intersection between the optical axis and the lens L is the optical center O. And moreover, the object focus F is located in front of the lens, two divisions on the optical axis, away from L. And F prime, the image focus, is the symmetric of F with respect to O. Now the point A is located on the optical axis, 3 divisions away from L. So this is the point A. And the point B is located above A by 1 division. A hat is found on B. Then now let's trace the object AB. Finally, the scale is given by 2 centimeters along the x-axis and 2 centimeters along the y-axis. So this is it for number 1. Now in number 2, they are telling me draw on the reproduced figure the image A1B1 of AB given by L. And by draw, then no justification is required. Notice that till this moment we didn't trace any ray issued from B. So then in order to trace the image A1B1 of AB given by L, we need to consider 2 incident rays that are issued from B. Then the first one that we'll consider is parallel to the optical axis. We know that it will emerge passing through the image focus like this. And we don't forget arrows on light rays that indicate the direction of propagation of light, which is from left to right. And the second ray that we'll consider issued from B is passing through the optical center. We know that it will complete its path without deviation. So I repeat here that no justification is required. And now let's trace the image A1B1 of AB given by L. So always the intersection of the emergent rays is the image of the object. So this is the intersection of these emergent rays that are coming from these incident rays that are coming from the point B. Therefore, this point will be the image of B, which is denoted by B1. So this is B1. Moreover, a hat is found on B directed away from the optical axis like this. Then we must place a hat on B1 directed away from the optical axis like this. So this is the hat. So this is the tracing of B1. Now because A represents the foot perpendicular of B on the optical axis, then A1 will represent the foot perpendicular of B1 on the optical axis. So this is the image A1, B1. Then done for part 2. Now in number 3 they are telling me give the nature and the direction of A1, B1. So let's start by the nature of the image A1, B1. So by the nature of the image we need to specify whether the image is real or virtual. So notice that the object AB is in front of the lens, and the image A1, B1 is behind the lens, and whenever the image and the object are on opposite sides, this means that the image is real. Then let's write, since the object AB and the image A1, B1 then the image A1, B1 is real. And in the same part they are telling me give the direction of the image A1, B1, then direction, and by the direction means that we need to specify whether it's inverted or erect with respect to the object. Then notice that the object AB is pointing upward and the image A1, B1 is pointing downward, which means that the image is in an opposite direction with respect to the object AB, which means it is inverted. Then let's write down the image A1, B1 is inverted with respect to the object AB. So this is it for number 3. Now in number 4 they are telling me determine graphically the height and the position of the image A1, B1. So the height represents the size of the image, and the position of the image A1, B1 represent the distance between the lens and the image. Let me make some space. Then let's start by calculating the height of the image A1, B1. So height or in other words the size of the image, which is denoted by A1, B1. So A1, B1 consists of two divisions, and we multiply by the scale along which you have counted the number of divisions, which is scale along the y-axis. This will give us 4. Since the scale is in centimeters, then the value of A1, B1 will be in centimeters. So A1, B1 is equal to 4 centimeters. Now it's left to calculate the position of the image A1, B1. So here, because the distance between the lens and the object is denoted by OA, so let's denote the position or the distance between the lens and the image to be OA1. So what does OA1 represent? OA1 represents the distance between the lens and the image, and this distance consists of 1, 2, 3, 4, 5, 6 divisions, and we multiply by the scale along which you have counted the number of divisions, which is scale along the x-axis. This will give us 12. Since the scale is in centimeters, then the value of OA1 will be in centimeters. So the distance lens image is given by 12 centimeters. Always, all quantities in physics must have unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. So this is it for the first experiment, which is the first part of this exercise. Now in the second part, they are telling me the object AB is now placed at a distance OA is equal to 2 centimeters from the optical center of the lens. So number one, they are telling me construct on a new diagram on the same previous scale the image A2B2 of AB given by L. Since they told me on a new diagram, then we need to construct a new optical system corresponding for the new position of the object, because now the object AB is at a distance OA is equal to 2 centimeters from the optical center of the lens. Whereas in the first part, the object AB was placed at a distance OA is equal to 6 centimeters. So let me make some space here. So now we are in the second experiment, part 1. Then let's construct the new optical system. The direction of propagation of light is taken to be from left to right. And whenever we need to construct the optical system, we always start by drawing the optical axis at the center, having the same direction, which is from left to right. So this is x prime, this is x. Then we place the lens L perpendicular to the optical axis at the center, using the correct symbol of a converging lens. So the intersection between the optical axis and the lens L is the optical center O. Now because we didn't change the lens, therefore the position of the foci will not change. F and F prime are symmetric with respect to O, and the focal length is given by 4 centimeters. So finally here the scale is given by 2 centimeters along the x-axis and 2 centimeters along the y-axis. So now we are ready to place the object AB in its new position. So here they gave us that OA is equal to 2 centimeters. So we need to locate the point A. Now because we are putting data along the x-axis, so we divide by the scale along which we are putting data. So dividing by 2 centimeters will give us 1 division. Then now we know that the point A is 1 division away from O. So this is the position of the point A. Now because we didn't change the object, so the size will not change. Then the point B will be located 1 division above A. And now let's trace the object AB. Then now what we have done is the construction of the new optical system. And now we are ready to construct the image A2B2 of AB given by L. And the word construct means that we need to trace and justify. Yet we didn't trace any ray issued from B. Therefore, in order to trace and justify the image A2B2 of AB given by L, we need to consider 2 incident rays issued from B in which we know how to complete their path. Therefore, the first one that we'll consider is parallel to the optical axis. We know that this ray will emerge, passing through the image focus like this. And we don't forget arrows on light rays. This is the tracing of the first ray. Now let's do the justification. So an incident ray issued from B parallel to the optical axis emerges passing through the image focus. And the second ray that we'll consider is passing through the optical center. We know that it will emerge without deviation. So now let's do the justification of this ray. An incident ray issued from B passing through the optical center emerges without deviation. Now we have done the tracing and the justification of the rays. Now we are ready to trace and justify the image. So always the intersection of the emergent rays is the image of the object. So notice that these two emergent rays, they don't intersect behind the lens, so this is behind the lens. Therefore, we need to prolongate them backward in order for them to intersect, because we require for the emergent rays to intersect. So let's prolongate them backward. This is the first emergent ray, so this is the prolongation. And this is the second emergent ray. So this is the prolongation of the second emergent ray. And the intersection of the prolongations is the image of the object. Which object? Notice that these prolongations are coming from these emergent rays that are coming from these incident rays that are coming from the point B. Therefore, this is the image of B, which is denoted by B2. Moreover, a hat is found on B directed away from the optical axis like this. Then we must place a hat on B2 directed away from the optical axis like this. This is the hat. Now let's do the justification of the tracing of the image B2. So what does the point B2 represent? Then the image B2 of B is the intersection of the prolongations of the emergent rays. Now here, because the image A2B2 consists of 2 points, we have done the tracing and the justification of B2. Now we need to trace and justify A2. In this case, A represents the foot perpendicular of B on the optical axis, then A2 will represent also the foot perpendicular of B2 on the optical axis. So this is A2. And now let's trace the image A2B2. Because B2 is the intersection of the prolongations and the prolongations are dotted, then the image A2B2 will be dotted. So A and A2 is the foot perpendicular of B2 on the optical axis. So this is it for number 1. Now in number 2, they are telling me give the nature and the direction of A2B2. Let me make some space here. So first let's start by the nature of the image A2B2. By nature, we need to specify whether the image is real or virtual. So notice that the object AB and the image A2B2 are on the same side of the lens, which is in front of the lens, which means that the image is virtual, because we know that whenever the object and the image are on the same side, then the image is virtual. And let's say since the object AB and the image A2B2 are on the same side, then the image A2B2 is virtual. And now the direction of the image A2B2, and by the direction we need to specify whether the image is erect or inverted. Notice that the object AB is pointing upward and the image A2B2 is also pointing upward, which means that the image and the object are in the same direction, which means it is erect. Then the image A2B2 is erect. With respect to the object AB. Now in number 3 they are telling me determine graphically the height and the position of the image A2B2, and by the height they mean the size of the image, and the position the distance between the lens and the new image A2B2. Then let's start with the height of the image A2B2. So A2B2 consists of 2 divisions, and we multiply by the scale along which you have counted the number of divisions, which is scale along the y-axis. This will give us 4. Since the scale is in centimeters, then the value of A2B2 will be in centimeters. So A2B2 is equal to 4 centimeters. Here, before I erase this, let me specify here or write down that the nature is virtual in the second experiment. Now, as for the position of the image A2B2, so the position here represents the distance between the lens and the image. Because the distance between the object and the lens is denoted by OA, then the distance between the lens and the image will be denoted by A2, OA2. And this distance, which is between L and A2B2, consists of 2 divisions. And we multiply by the scale along which you have counted the number of divisions, which is scale along the x-axis. This will give us 4. Since the scale is in centimeters, then the value of A2 will be in centimeters. Then OA2 is equal to 4 centimeters. Now, the final part, which is the conclusion. They are telling me in the first experiment the lens may be used as the objective of a slide projector, allowing us to obtain a magnified image on screen. What's the role of the lens in the second experiment? Justify. So they are asking me about the role of the lens in the second experiment. Always the role of the lens can be determined from the properties of the image. So notice that here the image A2B2 in the second experiment is virtual. Then let's say, since the image A2B2 is virtual, and moreover the image A2B2 consists of 2 divisions, while the object AB consists of 1 division, which means that the image is larger in size and larger in size. And we know that whenever the image is virtual and larger in size, then the role of the lens will be the magnifier. So the role, let me write, then the role of the lens is a magnifier. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.